Good day, I'm Dr. T and welcome to my office. So today I'd like to talk a little bit about density. Density is a property of matter. It's describing how much mass you have crammed into a specific unit of volume. This property can be useful to us in a couple of different applications. For starters, this is going to have both units of mass and volume. In reality, it can have any unit you would particularly like of each. However, traditionally, for solids and liquids, we are going to use a mass unit of grams and a volume unit of milliliters. Alternatively, you could use kilograms and liters, as those will actually produce the same number, and both will be used quite often. Gases typically are a good deal lighter. They have a lower density, so typically we use a unit of grams for the mass, but liters for the volume. This way it's going to be a larger number than what it would otherwise be had we used, say, grams and milliliters. Now, if I have two units, it's a compound unit, and I can use that as a conversion factor. So if I know the volume of a substance, I can calculate its mass, which may be particularly useful for me as a chemist. Or vice versa, if I know the mass of a substance, I can calculate its volume. Though there are a couple other applications for this. Different substances will have unique densities at a given temperature, so I can identify a substance by its density. Although there's only so many possible densities and lots of things will have the same density, so I won't necessarily be able to identify something specifically, but I can rule out alternative items. There's a classic story that's almost certainly not true, but the story goes that there was an ancient king in Greece, or ruler of a polis, and he had been given a crown, and the crown was supposed to have been made of gold. But rumor had it from his court that the goldsmith had embezzled some of the gold and replaced it with lead, and thus there was a problem. If the goldsmith had embezzled from him, he had to punish the goldsmith. If the goldsmith hadn't embezzled from him, then he had to punish those that were lying to him and trying to manipulate him. But the only way to know that was to know whether or not the crown was made of pure gold or not. So he goes to the smartest guy in the area, a guy by the name of Archimedes, and goes, here, please solve this problem. I'll give you a bunch of money if you do, and if you don't, well, I got to chop someone's head off. Archimedes, wishing to keep his head, ponders upon the issue of identifying that crown. See, he knew about density, and he could measure mass very well. The ancients had very good scales. Not, spectacular by today's standards, but still not bad. But there was a problem. He needed to find volume. The Greeks had worked out the volumes of various shapes, but a crown is an irregular shape, and he couldn't just beat it into that particular shape because, then he would destroy the crown, and that would end up with him not having a head either. So he hops in his bath, realizes that, hey, the water goes up. The water must go up because he displaced it, and thus comes the origin of volume by displacement. Sticking a solid object underwater, and the amount of water that it displaces causes the water to go up in volume, and therefore determining the volume of that object by the difference before and after with the water. And then the story presumably, although the story that I've heard doesn't continue on any further, the crown either had the density of gold, in which case the courtiers were probably executed, or it didn't have the density of gold, in which case the goldsmith lost his head. Another property of density, or another feature that we can look at with density, is that of buoyancy. So when something enters into a fluid, whether it be a gas or a liquid, it is going to start displacing that fluid. If the density is high enough, then it will simply displace as much fluid as it has volume and sink to the bottom. However, if the density is lower than that of the fluid in which it's in, it will displace fluid up until its mass, at which point it will stop sinking. Therefore, if you know the density of an object, you can know how far into the fluid it will submerge, or if it will go all the way under the fluid and will sink if its density is greater than that of the fluid. Now, I should point out when we're talking about density in really all three applications that density is dependent on temperature. As things heat up, the atoms vibrate a bit more and they tend to spread out. And thus, As they spread out, the volume changes, the mass does not, and therefore the density of the object changes. So whenever you're looking up a density table, there will typically be a value given as to the temperature with respect to that particular value on the density table. It's typically either 20 or 25 degrees Celsius, and most things don't change too awful much for a couple of degrees Celsius. But obviously, if you need very high precision numbers, or if your temperature is significantly off of kind of your standard room temperature, then this change in volume can become quite pertinent to you, and thus you'll need to look up a density for the material at that new temperature. This change in density also, by the way, is how things such as hot air balloons work, as air expands, lowering its density and thus floating when it's hot on cooler air, as well as your ocean currents and a lot of interesting weather and oceanographic features from varying densities of be it air or water due to temperature. So with that said, have a wonderful day, and I'll see you in later videos.